Hi everyone, so here's the first of our pulley questions from this morning's lesson, and I'm going to go through this first one step by step, and I'd like you to either correct it if you've done it already. If you need to correct it, mark it. If you've got it all correct, brilliant. If you haven't had a go of it yet, then can you please make sure you do, and then have a look at this video and make sure you've got a full correct version of each of these two questions in your notes. Okay, so let's have a look at this first one, and what I'm going to do, I'm going to add to the diagram the different forces acting in this question. Okay, now the first thing to say here, when we're reading this, we've got a light and extensible string, so the acceleration of A and B is going to be the same, and that's actually going to give us the answer to part B here, this one marker straight away anyway, but we'll put that in a second. And then this, where it's a smooth fixed plane, so the fact that it's smooth is really important, means we don't have to take any friction into account on the plane here. There's going to be no friction opposing the motion. Okay, so let's have a look at this. It's telling us that the system's released from rest, and we're asked to find the acceleration of the block and show that it's 4/7 g, and then we're asked to find the tension in the string, and after that we're asked to find this magnitude of the force exerted on the pulley here. So we'll have a look at these step by step, and as I say, make sure you get this fully corrected version into your notes. Okay, I'm just going to cover that over so we can add these forces that we know onto here. So we've got our weights acting vertically downwards first of all. So I've got my 2g there and my 5g there. I've got my tension in the string, and it's a light inextensible string. It's the same piece of string, light and extensible, so the tensions are the same for the whole system in both parts of the string here. What else have we got then here? We've got a reaction acting up the plane here. Sorry, perpendicular to the plane, not up the plane, perpendicular to the plane there. And there's our forces on there. There's no friction in this question because it was a smooth plane, so we don't need to add any friction here. So there's all my forces on my diagram. I'm going to now, though, look at here. We've got vertical components up and down. That's absolutely fine. Here, though, this weight is not acting parallel or perpendicular to the plane, and that's the way the motion's going to go, parallel to the plane. So I'm going to resolve this force parallel and perpendicular to the plane, and hopefully we're used to doing that now. So if I take my perpendicular component and my parallel components here, if this is 30, then this is going to be 30 as well. And we could use the fact that this is 60 in this right angle triangle, but as we've said before, in case this is alpha or theta or something like that, an unknown, it's always better to use this angle when we're looking at our resolved forces. But you don't have to, you could use 60 there, you get the same answers. So this angle's 30, which means this component is going to be 2g cos 30, because it's adjacent there. And so this one's going to be 2g sine 30, because it's equivalent to this part in this vector triangle. Okay, so there's our forces on our diagram. Let's have a look at what we're asked to find then. We're asked to show the acceleration is 4/7 g and find the tension in the string. Now this is definitely not going to be a SUVAT question because we've got no information about SUVAT in here, so it's going to be a forces only question by the looks of it. Okay, so let's have a look at our forces acting, and we're looking for the acceleration and then we're looking for the tension. I'm going to do both of those together. So I'm going to consider A and B separately. So looking at A, what have we got? We've got, if I looked at perpendicular to the slope, then I'd have r minus 2g cos 30 is 0, so r would be 2g cos 30, and that would be really important, you know, if we were asked for the reaction in the question, or if there was friction involved and the friction was overcome, so F max was equal to mu r, and then this would be really important to work out. In this question, I'm not actually interested in this here because I just want to know the tension and the acceleration. Just before I move on, I should have put which direction this was going in, and as we have a look at this, this one is acting 5g downwards, this one, so that's the force pulling the system this way. This one, we've got 2g sine 30 that way. So 2 sine 30 that way. So I'm just in radian mode. I'm just going to change my setup there. Hang on 1 second. Let me cancel that. Let me change my angles to degrees. Let's try that again. So this one's going to be 1G acting downwards this way. This is 5G, so the 5G is clearly going to work. And it seems pretty obvious in this question that's going to happen. It's going to go this way. In some other questions, it is important, and we'll see that in the next question, to make sure you work out which way this is going to go. So this is definitely going to go around that way as we expected. Our sort of common sense told us that, but we've checked it using the maths. So that's what's happening. Okay, let's have a look at this. I'm going to have a look at parallel to the slope. And I'm going to take that way as positive because that's my direction of motion. So here, resultant force equals MA. So my resultant force is going to be my tension, which is winning, minus my 2G sine 30. And that's going to be equal to 2 lots of A. So there's my first equation sorted. And again, here, sine 30 is just a half, so I can sort that out a little bit more and say that T minus G is equal to 2A. So there's one equation there. Now let's have a look at B. And B, the motion's downwards, so I'm going to take down as positive for B. So looking at B, the 5G is winning. The overall motion is going downwards, so 5G minus T is equal to MA, so 5A here. So again, that's using my resultant force equals MA equation. And there now, I've got 2 equations to sort this out. Okay, so we can look at these, and I'm going to maybe make T the subject of this. You can solve these simultaneous equations however you like, and sub that in over here. So I'm going to get 5G minus 2A minus G is 5A. So this is going to give me here here 5G minus T equals 5A. So this is going to give me here, if I'm looking at this, sorting this out, I'm going to get 4G is equal to 7A. So A is equal to 4G over 7, which is what we wanted in this question. So that's fine. And it doesn't matter here if you found T first, but that's what we're asked to find, acceleration. And then for part 2 of that question, I'm just going to sub this back in to find out my tension here. So subbing back in to find my tension. Let's say if I sub into this one, 2A plus G. So 2 lots of 4/7 G plus another G. Let's just do that on here. 4 lots of 4/7. And then add another one. And that's going to give me, let's have a look. I feel like I've done something wrong there. I don't know why I put a 2 there. Sorry, a 4 there. That should be a 2. Let me just do that again. So 2 lots of 4/7 plus my 1, 15 over 7G. And I'm going to leave it in terms of G, only because they left that one in terms of G. If you'd written it out and then multiplied this by 9.8, that would be fine as well. But in this question, I presume they want the answers in part in terms of G, because that's what they've done in this first bit of the question. Okay, part B we've already talked about. How have you used the fact that the string's inextensible? Well, we've used that to say that the tension was the same in both, so the acceleration's the same in both. So what's that mean here? For our use, it's the acceleration of A and B is the same. So for the whole system, it's acting as one. There's no stretch in that string. Okay, part C then. Now for part C, I'm going to add to my diagram here. Part C wants us to find the magnitude of the force exerted on the pulley by the string. It's a bit of a weird question, but it comes up every now and again. And I feel like we've maybe talked about this a little while ago when we were back in school, just chatted about it rather than did a question on it. But the force exerted on this pulley here, we're just talking about this now. We're just talking about the pulley. So the only forces acting on the pulley, the only thing that's actually affecting this is the bits of string. You know, the pulley doesn't know that there's a mass here and a mass here. All it knows is that this bit of string is pulling down on it. And the 2 forces there in this string are going to be the equal and opposite of these tensions. So, you know, if we considered sort of here, you've got a tension going that way and an equal and opposite tension going the other way. And we've seen that before when we've looked at splitting systems up into different sections and different particles, haven't we, with maybe the truck and the tow bar being connected with the tension between to something behind, to the trailer behind. It's that kind of idea, Okay, so looking here, if I'm looking just at this pulley, I'm just going to draw it down here really quickly. So I'm just looking at what's happening on this pulley. What's happening on this pulley then is that we've got the tension in the string that way and that way, pulling in these two directions. So overall, and these are both equal tensions, don't forget, so overall, that's going to be right through the middle of this. It's that force that we're looking for. Okay, I'm just going to call that P for pulley. Okay, so the force on the pulley is that P there. It's this force here. How are we going to do that then? Well, it's components of these tensions, because if we think about this, looking back up here, if this was 30 degrees, then this would be 60 degrees. So this whole angle is 60. And this, by the symmetry, these are both T. This has got to be right through the middle. So this must be 30 degrees and this must be 30 degrees. Hope you can see that. You might have to zoom in. Okay, so they're both 30 degrees. So then this component of this tension, you know, if I'm doing this component here, if I was splitting this up, I'm not bothered about that one. I'm just looking at this component. So this component of the tension here that's acting on this pulley, acting downwards this way, this is going to be T cos 30 from this bit of the tension, and this is also going to be T cos 30 from this bit of the tension. That's what's acting in this direction. Okay, so that's what's acting on the pulley in this direction. So P is going to be equal to 2 lots of T cos 30, and I've got my T from here, so 2 lots of 15 G over 7 times cos 30. I'm going to leave it in terms of G again, so 2 times 15 over 7 times cos 30. So I'm going to get a in this, aren't we? So this is going to be 15 root 3 over 7 G newtons. And again, you know, depending on the question, we might have left it like this, depending on what they wanted, or we might have just typed this in, times it by 9.8, got an answer to 3 significant figures. But there's my final answer there. Sorry, I forgot to change back to black pen. 15 root 3 over 7G. So that's that question finished. Make sure, as I say, that you've got a full version of that question in your notes, please. I'm going to stop the video there. So I'd like you to go through that, make sure you've got all the steps down, and then I'm going to have a look at question 2, and that'll be in the next video.